July 10, 1942. The Aleutian Islands, Alaska Territory. Through the observation window of a PBY Catalina patrol plane, machinist Mater Albert Knack pressed binoculars against his face, his pulse quickening at what he saw below. Red circles painted on wings, the unmistakable rising sun emblems of Imperial Japan, sitting there in the wetlands like a gift. A Japanese Zero fighter, apparently intact, resting upside down in the grass. Lieutenant William Thies, piloting the patrol aircraft, had gotten lost in the notorious fog banks that turned the Aleutian chain into a navigational nightmare. Using dead reckoning to reorient over the Shumagin Islands, he chose the most direct route back to Dutch Harbour, a route rarely flown by American aircraft, a route that would fundamentally change the Pacific War. Knack thought they must be hallucinating from exhaustion. No Japanese pilot would abandon such a valuable machine without destroying it first. For over a year, this aircraft had been the absolute terror of Pacific skies, the mystery weapon that had shredded American, British and Chinese air forces with contemptuous ease. At Pearl Harbor, over the Philippines, across Burma and Malaya, the Zero had achieved what seemed impossible. A carrier-based fighter that outperformed land-based interceptors in nearly every category. As Thies circled the crash site 3 times, marking the position carefully, neither man knew what they'd found. A prize almost beyond value to the United States. What they were about to recover would expose the most profound paradox in aircraft design philosophy of the entire war. A paradox written not in technical manuals but in the lives saved and battles won. The Zero's reputation had been built on a foundation of fear and mystery that gripped every Allied pilot. In the 7 months since Pearl Harbor, American pilots had encountered an aircraft that defied every assumption about Japanese capabilities. Fast, maneuverable and long-ranged, it dominated Pacific skies with an authority that seemed unbreakable. In early engagements over China, Zeros achieved kill ratios as high as 12-1 against obsolete fighters. In April 1942, a Japanese strike force with 36 Zero fighters attacked Ceylon, shooting down 27 British aircraft for the loss of just 5 Japanese planes. The official American strategy when encountering a Zero was simple and humiliating. Run away immediately, avoid engagement at all costs, do not attempt to dogfight under any circumstances. These orders came not from cowardice, but from brutal mathematics written in blood. American fighters that tried to turn with Zeros died quickly. Pilots who attempted traditional aerial combat tactics against this nimble adversary rarely survived to report their mistakes. The Zero seemed invincible, untouchable, superior in every way that mattered. June 4, 1942. The same day as the pivotal Battle of Midway, 1,500 miles to the south. As part of Japan's complex operation to seize Midway Atoll, a diversionary force struck the Aleutian Islands to draw American attention northward. 19-year-old Flight Petty Officer Tadayoshi Koga launched from the Japanese carrier Ryujo as part of the second strike against Dutch Harbour. His Zero serial number 4593 was part of a 3-plane section assigned to strafe the American naval base. Koga and his wingmen, Chief Petty Officer Makoto Endo and Petty Officer Suguo Shikada, dove on the harbour with devastating effect. They shot down an American PBY-5A Catalina flying boat and strafed survivors in the water with machine gun fire. But during the attack, small arms fire from defenders on the ground struck Koga's aircraft by chance. A bullet severed an oil line in the engine compartment. Not catastrophic immediately, but fatal within minutes as precious engine oil sprayed into the cold Alaskan air. 25 miles east of Dutch Harbour sat Akutan Island, pre-designated by Japanese planners as an emergency landing field. A Japanese submarine waited offshore specifically to rescue downed pilots from operations in the area. As Koga's oil pressure dropped rapidly, he signaled his wingmen and turned toward Akutan for an emergency landing. From above, the grassy flat inland from Broad Bight looked perfect for an emergency landing. Solid, inviting, safe to the eye. Shikada, circling overhead watching his friend, suddenly noticed water glistening between the grass stalks in the sunlight. He realized with horror that the ground was not firm earth, but marshland that would trap the aircraft. He tried desperately to signal Koga to make a belly landing with gear up. But it was too late for communication. Koga had already lowered his landing gear and committed to a conventional landing approach. The Zero's wheels touched the grass and immediately sank into the soft mud beneath the surface. The aircraft pitched forward violently, flipping end over end in a cartwheel. It came to rest upside down, wings and fuselage nearly intact but inverted. Inside the cockpit, Tadayoshi Koga died instantly, his neck broken by the tremendous impact forces. Endo and Shikada circled the wreckage above, torn by conflicting orders that paralyzed them. Every Japanese pilot carried explicit instructions to destroy any Zero that crash-landed in enemy territory by strafing it. The aircraft's secrets were too valuable to allow capture. But Koga might still be alive inside that overturned cockpit. They could not bring themselves to strafe their friend without knowing for certain. After several agonizing circles, low on fuel and with weather closing in rapidly, they turned west toward their carrier. They believed a Japanese submarine would retrieve Koga soon and everything would be fine. The submarine searched for hours in the rough seas but was driven away by the USS Williamson, an American destroyer patrolling the area. Koga's body remained in the cockpit, suspended by his harness. The Zero sat undisturbed in its marsh, invisible from standard flight paths, unknown to American forces in the region. 1 month passed with the Zero hidden by fog and rain. Then Albert Nack spotted what looked like a small aircraft through a break in the clouds. On July 11th, Lieutenant Thies returned with a landing party of armed sailors. They approached the overturned Zero cautiously, weapons ready, unsure what they would find or if it was a trap. Chief Aviation Pilot William Scarborough, an experienced Navy pilot assigned to the recovery team, waded through the marsh to reach the aircraft. He peered into the inverted cockpit and found Koga's body still strapped in the pilot's seat. The recovery team stood in silence for a moment, studying the aircraft that had terrorized American pilots across thousands of miles. Even inverted and damaged, the Zero possessed an almost predatory elegance that was immediately apparent. Sleek lines, minimal protrusions, a design that whispered speed and agility, even sitting broken in mud. They photographed the wreckage from every angle, documenting their find meticulously before attempting recovery. Koga was removed from the cockpit and given a Christian burial nearby with military honors. Whatever their nation's conflict, he was a warrior who deserved respect in death. Then the real work of examination began, and what they discovered would shock every engineer. The team carefully examined the Zero's structure, noting every detail with growing amazement. What they observed in those first hours would prove as significant as the test flights to come. The aircraft was remarkably light in ways that defied American engineering assumptions, not just in overall weight, but in every single component and assembly. The skin felt thin under their hands, almost fragile compared to American aircraft. Scarborough tapped the fuselage and heard a hollow sound that reminded him of a tin can, not a combat aircraft. He looked for armor plating around the cockpit where every American fighter had protection. Found none whatsoever. He searched for armored glass in the windscreen to protect the pilot. Found standard clear panels that would stop nothing. He inspected the fuel tanks expecting self-sealing technology. Discovered they were nothing more than simple aluminum containers with no protection. This was wrong according to everything American aircraft designers believed about fighter construction in modern warfare. Combat aircraft were being built with progressively more protection as the war taught harsh lessons. Armor behind the pilot's seat to stop bullets from behind. Armored glass windscreens to survive head-on attacks. Self-sealing fuel tanks with rubber bladders that swelled shut when punctured by bullets. These features added substantial weight to aircraft, hundreds of pounds, but saved pilots' lives consistently. The Zero had absolutely none of these protective features that American designers considered mandatory. 3 recovery attempts were needed due to the notoriously terrible Aleutian weather. Sudden storms and impenetrable fog frustrated initial efforts repeatedly. On July 12, a recovery team led by Lieutenant Robert Kermsey gave Koga a proper Christian burial, replacing the hasty grave. Then they attempted to recover the aircraft, but the ship lost its anchors in the rough conditions. Finally, on July 15th, a barge reached the site successfully through the weather. Workers constructed a makeshift sledge to drag the Zero through the marsh to the beach for loading. The aircraft, even waterlogged and damaged, weighed remarkably little for its size. 6 men could maneuver it with effort. The Zero was loaded onto the USS St. Mihiel and transported to Seattle, arriving August 1st after a slow journey. From Seattle, it traveled by barge to Naval Air Station North Island near San Diego, California, for analysis. The journey took the better part of a month while anticipation built. During that time, American intelligence officers pored over photographs, debating intensely what they had captured. At North Island, the Zero was placed under 24-hour military police guard with shoot-to-kill orders, not just to prevent sabotage, though that was a concern, but to prevent souvenir hunters from dismantling the aircraft piece by piece. Every mechanic, every pilot, every engineer wanted a fragment of the legendary fighter for themselves. The guards had explicit orders to shoot anyone attempting unauthorized access to the prize. Navy mechanics began the meticulous repair work under intense time pressure. Experienced aircraft technicians approached the Zero with professional curiosity mixed with deep suspicion. Japanese aircraft were rumored through propaganda to be crude copies of Western designs built with inferior materials. They expected to find a clumsy imitation constructed with sloppy workmanship. What they found instead astonished every single person who examined it closely. The Zero was a masterpiece of weight reduction engineering, executed with brilliant precision. Every component had been designed with obsessive attention to minimizing mass without sacrificing strength. The main wing spars were constructed from extra super duralumin, a lightweight aluminum alloy developed by Sumitomo Metal Industries in 1936. This alloy combined zinc with aluminum to create a material that was lighter and stronger than standard aircraft aluminum, though prone to corrosion, which was a trade-off. The Japanese had countered this weakness with a zinc chromate coating applied after fabrication. It was sophisticated metallurgy equal to or ahead of American capabilities at that time. Structural components revealed ingenious weight-saving measures throughout the design that showed deep engineering thought. Wing attachment fittings were minimized by permanently bonding wings to the fuselage, eliminating massive removable joints. The aft fuselage detached just behind the cockpit for maintenance while keeping forward structure light and simple. Engine placement near the wing's leading edge allowed a shorter, lighter tail section. Control surfaces used fabric covering, where American designs employed heavier metal skin for durability. Landing gear struts were narrower than American equivalents, saving weight but reducing strength. The cockpit framework was minimalist, offering excellent pilot visibility in all directions, but no protection whatsoever from enemy fire. The repair team straightened the bent vertical stabilizer, rudder, wing tips, flaps, and canopy with careful metalwork. Their landing struts, sheared off completely during the crash, required complete replacement with fabricated parts. The 3-blade Sumitomo propeller was dressed and reused despite damage. Even damaged, it remained serviceable, testament to Japanese manufacturing quality that impressed American inspectors. As repairs progressed, detailed measurements revealed stunning specifications. The A6M2 weighed 5,555 pounds, fully loaded with fuel and ammunition. The Grumman F4F4 Wildcat, America's primary carrier fighter at the time, weighed 7,426 pounds in combat configuration. The Zero was 1,871 pounds lighter, nearly a ton of difference. That weight gap translated directly into performance advantages. The Zero's Nakajima Sakai 14-cylinder radial engine produced 950 horsepower at maximum output. The American fighter had 250 more horsepower, but carried 2,000 more pounds of weight. Power-to-weight ratio favored the Zero decisively in acceleration and climb. Wing loading told the same story in different numbers. The Zero carried 24.3 pounds per square foot of wing area due to large wings. The Wildcat carried 28.6 pounds per square foot with smaller wings. Lower wing loading meant the Zero could turn tighter, climb faster, and maneuver more aggressively in combat. But as mechanics examined the fuel system in detail, they found something that troubled them deeply and changed everything. The fuel tanks were simple aluminum containers, thin-walled, completely unprotected from gunfire. American aircraft used self-sealing tanks with multiple layers of specialized materials. An outer layer of rubber, a middle layer of vulcanized fabric, and an inner layer that swelled when punctured. These self-sealing tanks added significant weight to aircraft, reducing performance and fuel capacity noticeably. They were heavy, expensive, and reduced fuel capacity by taking up space, but they saved pilots' lives consistently. A single bullet through a standard tank meant fire and death almost instantly. A bullet through a self-sealing tank meant a small leak, manageable and survivable in most cases. The Zero had chosen performance over survival in the starkest terms possible. Every Japanese pilot flying this aircraft knew that a single bullet in the fuel system meant probable death by fire. There would be no leak, no gradual fuel loss, no chance to nurse a damaged aircraft home safely. There would be ignition, explosion, catastrophic fire that consumed everything. American pilots had reported Zeros bursting into flames from minimal damage in combat. Now the reason was crystal clear in the physical evidence. The lack of pilot armor was equally shocking to American sensibilities about combat aircraft. American fighters mounted thick steel plates behind the pilot's seat, adding substantial protective weight to guard against enemy fire from behind. The most common attack angle in aerial combat throughout history. The Zero had nothing behind the pilot but thin aircraft skin. A pilot's seat was a thin metal frame with a fabric cushion offering zero protection. A .50 caliber machine gun bullet would pass through the seat and the pilot with equal ease, killing instantly. The windscreen used standard glass, perhaps slightly thicker than civilian aircraft, but offering no ballistic protection whatsoever. American fighters increasingly mounted armored glass, heavy transparent plates that could stop small arms fire and shell fragments. The Zero saved the weight and left its pilots completely vulnerable to head-on attacks. September 20th, 1942. 2 months after the crash, Lieutenant Commander Eddie Sanders climbed into the cockpit of the repaired Zero for its first test flight. Sanders was one of the Navy's most experienced test pilots, a man whose life depended on accurate assessment of aircraft capabilities. He settled into the lightweight seat, noting immediately how cramped the cockpit felt compared to American designs. The engine started smoothly with a distinctive sound. Japanese engineering, whatever its other qualities, produced reliable power plants that ran well. Sanders taxied carefully, aware that the narrow-track landing gear made ground handling tricky and unforgiving. He advanced the throttle and felt the aircraft accelerate with surprising eagerness that caught him off guard. Takeoff roll was remarkably short compared to American fighters. The Zero lifted off and climbed with an immediacy that startled him despite his extensive experience. At altitude, Sanders began systematic testing according to his flight test protocol. He started with basic handling characteristics first, level flight, gentle turns, climbs and descents to understand the aircraft. The controls felt light, almost sensitive to touch. Small stick movements produced immediate aircraft response that felt almost nervous. After years flying American fighters, the Zero felt like switching from a heavy truck to a sports car. He pushed the test envelope further with more aggressive maneuvers. Maximum speed runs revealed the Zero could reach approximately 330 miles per hour, faster than the Wildcat. but not dramatically so. But then he attempted a hard roll at cruise speed testing maneuverability. The ailerons, the control surfaces that produced roll, suddenly stiffened dramatically under his hands. Above 200 knots indicated airspeed. Rolling maneuvers became slow and sluggish, requiring excessive force on the control stick. Sanders tried rolling left, then right to compare. The aircraft rolled to the left much easier than to the right, showing clear asymmetry. This asymmetry would be crucial tactical information for American pilots in combat situations. In a dogfight, a Zero pilot would naturally prefer left rolls where the aircraft responded better. Knowing this, an American pilot could exploit the tendency, forcing the Zero into right rolls where it was slower and less responsive, gaining precious seconds. The next test was potentially lethal but necessary to understand vulnerabilities. Sanders put the Zero into a dive, then pulled hard on the stick to generate negative acceleration forces. The engine coughed, sputtered, and quit completely. Silence except for windstream rushing past. He was flying a glider at 3,000 feet over the California coast with no power. Sanders maintained composure through training, leveled out smoothly, and the engine restarted after positive G returned. He repeated the test twice more, with identical results that confirmed the flaw. The Zero's float-type carburetor, which relied on gravity-fed fuel delivery, could not handle negative G-forces at all. Under negative acceleration, fuel flow to the engine stopped completely and instantly. This was the answer American pilots desperately needed to survive encounters with Zeros. When being pursued by a Zero, don't turn and don't try to outmaneuver it in horizontal combat. Instead, push the stick forward hard, diving with negative G-force. The American aircraft with its pressure-tight carburetor would continue running perfectly. The Zero's engine would quit every single time. In those crucial seconds of silence, an American pilot could open range rapidly and escape certain death. Sanders flew 24 test flights between September 20th and October 15th, each revealing new details. Each flight revealed new tactical information that could save American lives in combat. The Zero's famous maneuverability was absolutely real, but came with significant limitations that could be exploited. At low speeds below 200 miles per hour, it could turn inside any Allied fighter with ease. But at high speeds above 250 miles per hour, it became stiff and sluggish in turns. American fighters, heavier and more powerful, gained advantages as speed increased beyond certain thresholds. The test data was compiled into technical reports distributed to every fighter squadron in the Pacific theater. Pilots read with intense interest about the enemy aircraft that had haunted their nightmares for months. The report confirmed what some experienced pilots had begun to suspect through hard-won combat experience. The Zero could be beaten decisively, not by fighting its fight, but by imposing a different type of combat entirely. Commander John Thack had already developed his famous Thack Weave maneuver before the Akutan Zero was recovered, first using it in combat at Midway on June 4, 1942, the same day Koga crashed. Working from intelligence reports about the Zero's capabilities, Thack devised a defensive tactic where two Wildcats flying side by side would weave toward each other when attacked. This brought pursuing Zeros into the other plane's gun sights in a mutual support pattern. But the captured Zero validated and expanded his theories significantly, providing precise data on limitations. American pilots learned to fight Zeros using boom and zoom tactics that played to their strengths. Gain altitude advantage first. Dive at high speed building energy. Make a single firing pass with guns blazing. Continue diving past the target without slowing. Use superior dive speed to zoom back to altitude using momentum. Repeat the process until the enemy is destroyed or retreats. Never get slow where the Zero has advantage. Never try to turn with a Zero in horizontal combat. Use American advantages in diving speed, structural strength, and pilot protection relentlessly. The captured Zero was flown against every American fighter type in mock combat. Mock dogfights pitted it against Wildcats, P-38 Lightnings, P-40 Warhawks in controlled conditions. Each engagement was filmed and analyzed frame by frame for tactical lessons. Pilots learned firsthand how to exploit the Zero's weaknesses systematically. The ailerons freezing at high speed, limiting roll rate, the engine cutting under negative G-forces every time. The inability to dive as fast as heavier American fighters without structural risk. But the most important revelation was psychological rather than technical. The Zero was not invincible like propaganda claimed. It was an excellent aircraft, brilliantly designed for specific missions and doctrines. But it had vulnerabilities that could be systematically exploited. It could be defeated by informed pilots using proper tactics. American pilots who had felt outclassed and helpless now had concrete answers to their problems. They had proven tactics. They had hope for survival. Lieutenant Commander Eddie Sanders wrote in his official report with barely contained excitement. These flights covered performance tests such as we do on planes undergoing Navy tests. The very first flight exposed weaknesses which our pilots could exploit with proper tactics. Immediately apparent was the fact that the ailerons froze up at speeds above 200 knots. Rolling maneuvers at those speeds were slow and required much force on the control stick. The knowledge spread through the fleet like wildfire, carried by enthusiastic pilots. Fighter squadrons immediately modified their training based on the new intelligence. New pilots learned boom and zoom before they ever faced a Zero in actual combat. Veterans shared the intelligence with relief and vindication for their earlier losses. Their sacrifices had not been in vain after all. The losses of those early desperate battles had bought time for this knowledge to reach them. Marine pilot Lieutenant Colonel Kenneth Walsh, credited with 21 confirmed kills and awarded the Medal of Honor, later said something profound. Knowing what to do with a Zero on my tail, information that came from Koga's Zero, saved my life several times in combat. Walsh's tactical knowledge derived from the captured aircraft enabled him to survive encounters that would have been fatal otherwise. Fighter ace William Leonard, who would retire as Rear Admiral with 6 confirmed victories, stated emphatically, "The captured Zero was a treasure trove of information. To my knowledge, no other captured machine has ever unlocked so many secrets at a time when the need was so great." Japanese military historian Masatake Okumiya, a lieutenant general in the Japan Air Self-Defense Force after the war, wrote something remarkable. The revelations from the Akutan Zero were as dire for the Japanese military as the loss at the Battle of Midway itself. But the Akutan Zero's influence extended far beyond tactics into aircraft design philosophy. American aircraft designers studied the wreckage intensely, measuring and analyzing everything. Grumman had already begun work on the F6F Hellcat to replace the outmatched Wildcat before the capture. The Hellcat's design had been partially influenced by intelligence reports from pilots who fought Zeros at Coral Sea and Midway. The first production F6F-3 made its first flight on October 3, 1942, just weeks after Sanders began testing the Akutan Zero. But the captured Zero provided hard empirical data to validate design choices already made. The Hellcat that entered service in January 1943 incorporated lessons from understanding the Zero's strengths and weaknesses. It was faster with a maximum speed of 380 miles per hour, significantly better. It had a rate of climb that matched or exceeded the Zero in most altitude ranges. It retained armor protection and self-sealing fuel tanks that added weight, but was designed to fight Zeros on more favorable terms. The Hellcat also incorporated knowledge of the Zero's specific weaknesses into its design philosophy. It was designed to excel at high-speed combat, where the Zero struggled with control stiffness. Its powerful Pratt & Whitney Air 2800 double Wasp engine produced 2,000 horsepower, more than double the Zero's output. This enormous power enabled boom and zoom tactics effectively, allowing Hellcat pilots to dictate engagement terms. In November 1943, the Akutan Zero was displayed at Washington National Airport as a war prize. During celebrations of the 25th anniversary of airmail service, thousands of Americans viewed the aircraft firsthand, the aircraft that had terrorized the Pacific, sitting there for public viewing. The Zero looked sinister, predatory, dangerous, even sitting still on display. Few viewers understood that they were looking at the physical embodiment of a fundamentally different design philosophy. In 1944, the Zero was recalled to North Island for use as a training plane for new pilots. Fresh pilots flew against it in mock combat, learning its capabilities and limitations in controlled conditions. A Model 52, captured during the liberation of Guam, joined it for additional training purposes. American pilots who would face Zeros over the Philippines, Iwo Jima and Okinawa first fought the Akutan Zero in California skies, building experience and confidence before facing the real thing in combat, where mistakes meant death. The contrast between American and Japanese aircraft design philosophy became starker as the war progressed through years. American designers continuously improved fighter protection as combat experience accumulated. The F4U Corsair, entering service in 1943, featured armor, self-sealing tanks, and overwhelming power from its 2,000 horsepower engine. The P-38 Lightning mounted twin engines and heavy armament while protecting its pilot with armor and redundancy. Japanese designers attempted to add protection to later Zero models based on combat losses. The A6M5 variant introduced in 1943 included a 55mm armored glass windscreen finally, and an 8mm armor plate behind the pilot's seat for minimal protection. But these additions increased weight substantially without corresponding power increases to compensate. The Nakajima Sakai engine remained limited to around 1,000 horsepower maximum. Weight increased 28% from the A6M2. Horsepower increased only 16%, creating imbalance. The later Zeros were slower, less maneuverable and less effective than the A6M2 that Koga had flown. Japanese engineers had tried to adopt American protection philosophy under pressure from pilots, but lacked the powerful engines needed to maintain performance with the added weight and drag. The result was a fighter that had lost its primary advantage without gaining compensating strengths in other areas. By 1944, American fighter pilots dominated Pacific skies with overwhelming superiority. The Great Marianas Turkey Shoot in June 1944 saw devastating Japanese losses that shocked observers. Allied fighters and anti-aircraft guns shot down over 500 Japanese warplanes in a single engagement. American losses included approximately 43 aircraft in combat and 80 more to operational accidents during night operations. Inexperienced Japanese pilots flying Zeros against veteran Americans in Hellcats and Corsairs faced overwhelming odds. Japanese pilot attrition was catastrophic and unsustainable for their training system. The experienced aviators who had attacked Pearl Harbor, who had dominated early Pacific campaigns, were being systematically killed. Japan's training pipeline could not replace them fast enough with quality pilots. Replacement pilots had less training, less experience, less chance of survival in combat. The quality gap widened month by month until it became insurmountable. In October 1944, during the Battle for the Philippines, Zeros began to be used in kamikaze attacks. When aircraft could no longer compete effectively in conventional combat, they became guided missiles with human pilots. Pilots were ordered to crash their aircraft directly into American ships in suicide attacks. Kamikazes used A6M fighters more than any other aircraft for these desperate suicide missions. The Zero, designed to dominate dogfights over China, ended its career as a disposable weapon. The design philosophy that created the Zero had been based on assumptions that proved fatally flawed in practice. Japanese planners believed the war would be short and decisive in their favor. They planned to strike decisively, defeat the Americans quickly, and negotiate from a position of strength. In a short war lasting months, pilot attrition would not matter significantly. Long-term survival rates would be irrelevant to victory. What mattered was immediate combat effectiveness to win quick battles. They also believed their pilots were inherently superior to Western pilots. that intensive training and warrior spirit would compensate for any material disadvantages in equipment. Both fundamental assumptions failed catastrophically as the war dragged on for years. The war was not short, but lasted 4 years of brutal attrition warfare. And American pilots, initially less experienced, learned quickly from combat. Combat experience accumulated among survivors. Tactics evolved based on what worked. Training improved, incorporating lessons learned. By 1943, American pilots were equal to Japanese pilots in average skill level. By 1944, with veteran Japanese pilots dead and inexperienced replacements facing combat, Americans held a decisive skill advantage. The Zero's lack of protection, acceptable in a short war, became catastrophic in a long war of attrition. A pilot in a protected American fighter might survive being shot down once, twice, even multiple times through war. He would bail out, be rescued by friendly forces, return to combat duty. He would learn from each encounter, becoming more effective with each mission flown. A Zero pilot shot down once was likely dead with no recovery possible. No second chance, no learning curve, no accumulated experience over time. Every Zero shot down meant one experienced pilot lost forever to Japan's war effort. In May 1937, the Imperial Japanese Navy issued specifications for a new carrier fighter to replace aging types. The requirements were daunting and seemed nearly impossible to meet with available technology. Maximum speed of 310 miles per hour at 13,120 feet altitude was demanded. Climb to 9,840 feet in just 3 minutes, 30 seconds. Armament of 2 20mm cannons and 2 7.7mm machine guns for heavy firepower. Full radio and direction finder for navigation, plus critically range sufficient to escort bombers over vast Pacific distances. Meeting those requirements with available engine technology seemed impossible to most designers. Nakajima Aircraft Company concluded the specifications could not be met realistically and withdrew from the competition entirely. Only Mitsubishi remained in the competition, with chief designer Jiro Horikoshi accepting the seemingly impossible challenge. Horikoshi later wrote candidly, "Instead of pondering the future of the aircraft, our immediate goal was to win the contract." Horikoshi's solution was radical and would define the Zero's character. Make the aircraft as light as possible through extreme measures. Eliminate everything not absolutely essential to meeting the specified requirements in the contract. Armor was not mentioned in the Navy's requirements document. Self-sealing tanks were not mentioned anywhere. Therefore, both were omitted completely to save weight. Weight saved could be used for fuel, enabling the required long range. Lightweight construction enabled the required maneuverability and climb rate. The decision reflected Japanese military doctrine that prioritized offensive capability above all else. Attack was emphasized in training and philosophy. A warrior accepted risk as inevitable and sought maximum effectiveness in combat. The captured Akutan Zero exposed this philosophical divide to American analysis with stunning clarity. US Navy reports noted that the Zero was designed purely for the attack role exclusively, emphasizing long-range maneuverability and firepower at the expense of protecting its pilot's life. American designers had made fundamentally different choices based on different values. Protection was not weakness but sound engineering. Survival was not cowardice but tactical necessity. A pilot who lived to fight again was more valuable than one who died in a single engagement. No matter how effective that single engagement might be in isolation, the industrial implications were equally profound and favored American philosophy. An armored, protected aircraft was more expensive to build and required more materials, took longer to manufacture with more complex systems, but it lasted longer in combat service, and more importantly, its pilot lasted longer. Japan could build aircraft faster than it could train replacement pilots to fly them effectively. America could train pilots faster than Japan could build replacement aircraft with limited resources. The mathematics of attrition favored the side that protected its people over equipment. After the war ended, captured Japanese aircraft designers were interviewed by American technical intelligence teams. Their testimony confirmed what the Akutan Zero had revealed physically. The lack of armor and self-sealing tanks was not oversight or incompetence. It was intentional design choice based on tactical requirements and operational philosophy. Jiro Horikoshi stated in his post-war memoir that armor protection was never mentioned in initial design requirements. Weight restrictions meant prioritizing armament, range, and maneuverability over everything else. Japanese military doctrine assigned low priority to armor protection traditionally. The underlying attitude was that such protective features were luxuries rather than necessities for warriors. Only after wholesale attrition of irreplaceable pilots did they finally see the truth. That living to fight another day was more important in modern warfare than achieving maximum performance in a single engagement. The American pilots who flew the Akutan Zero came away with profound respect for Japanese engineering skill. Combined with recognition of the design's fundamental vulnerability to combat damage. Test pilot Edward Sanders later wrote that the Zero was the finest aircraft he had ever flown at low speeds. Its maneuverability was extraordinary, its handling delightful, controls responsive, but he would never want to take it into combat against determined opposition. One bullet could kill you instantly. The aircraft gave you no protection, no second chance for survival. Captain Eric Brown, the Royal Navy's chief test pilot who flew more aircraft types than anyone, flew a captured Zero post-war. He called it the most maneuverable fighter he had ever flown in his extensive career. He could turn inside any Allied aircraft with ease. But he also noted the complete absence of armor or protected fuel tanks, and called it a death trap. Beautiful to fly, terrible to fight in, he concluded. The fate of Tadayoshi Koga, the 19-year-old pilot who crashed on Akutan Island, became symbolic of the Zero's flawed philosophy. Koga was an experienced, skilled aviator who had survived multiple combat missions, but a single bullet through an oil line meant his death on a remote island. If his aircraft had been designed with survival in mind, if vital systems had been protected with armor, he might have made it back to his carrier safely. He might have fought again in future battles. His experience and skill might have been preserved for Japan's war effort. Instead, he died in an Alaskan marsh, his sacrifice inadvertently contributing to American victory through his aircraft's capture. The aircraft he died in became the teacher that trained his enemies in how to kill other Zero pilots. The secrets he never intended to reveal were extracted from the wreckage by a foreign power. His death and his Zero's capture changed the war's course in ways he could never have imagined. In February 1945, the Akutan Zero met an ignominious end far from combat glory. It was being ferried from San Diego when Commander Richard Crommelin was taxiing the Zero at Andes North Island. A Curtiss SB-2C Helldiver crashed into it during ground operations in a mundane accident. The aircraft was damaged beyond economical repair. It was scrapped shortly thereafter, its service complete, but the intelligence it provided lived on forever. Thousands of American pilots owed their lives to the tactics developed from studying Koga's Zero over months. The Hellcat's design reflected lessons learned from understanding the captured aircraft's strengths and weaknesses. The boom and zoom tactics, the understanding of the Zero's high-speed limitations, the exploitation of its carburetor weakness, all stemmed directly from the Akutan Zero's systematic test flights. The parallel development of American and Japanese fighters told the larger story of diverging philosophies. American aircraft became progressively more protected, more powerful, more capable as the war continued. The F6F Hellcat gave way to the F8F Bearcat, an even more powerful and protected fighter design. Japanese aircraft tried to add protection, but lacked the industrial capacity to do so effectively. The performance gap widened until Japanese aircraft were obsolete by 1944 standards of aerial combat. The ultimate lesson of the Akutan Zero was not technical but philosophical about war itself. Aircraft design reflects cultural values and strategic assumptions of the nations that build them. The Zero reflected Japanese values of offensive capability, acceptance of risk, and belief in short, decisive war. American fighters reflected values of pilot protection, long-term attrition warfare, and industrial sustainability. In a long war of attrition between industrial powers, the American philosophy proved superior in results. This did not make American pilots braver or more skilled than their Japanese counterparts. It made them more likely to survive combat encounters and return home. Survival meant experience accumulation. Experience meant increasing effectiveness. The cycle compounded over time until American air superiority became absolute and unchallengeable. The Zero's lack of protection, initially an acceptable trade-off for performance, became the fatal flaw. A flaw that destroyed Japanese air power progressively through attrition. Modern historians studying the Pacific Air War inevitably return to the Akutan Zero as a turning point. The capture did not change aircraft that were already in production at factories. It did not directly influence the Hellcat's initial design, which was already well advanced, but it changed American understanding of the enemy fundamentally. It revealed vulnerabilities that could be systematically exploited in combat. It provided hope when hope was desperately needed most. In July 1942, America was losing the Pacific War badly. 6 months after Pearl Harbor, American forces were retreating across the Pacific theater. Zeros dominated the skies wherever they appeared. The Akutan Zero arrived at precisely the moment when American morale needed a boost desperately, when tactical innovation was essential for survival, when understanding the enemy was critical. Lieutenant Commander Sanders' first test flight report circulated through naval aviation like electricity through a wire. Pilots read and reread the section about the Zero's engine cutting under negative G-forces repeatedly. Finally, a concrete answer to their prayers. Finally, a way to escape certain death. Push the stick forward hard. Dive with negative G. The Zero's engine would quit every time. Your engine would keep running. You would live to fight another day. That single tactical revelation saved hundreds of American lives over the following years. Marine pilots at Guadalcanal, Navy pilots at Santa Cruz, Army pilots in New Guinea, all applied the lesson. They survived encounters they would otherwise have lost to superior Japanese maneuverability. They returned to base to fight again another day. Their experience accumulated, their skills improved with each mission, and gradually the balance shifted. The captured Zero also affected Japanese strategy when they learned of the capture. When word reached Japanese intelligence that an intact Zero had been recovered, there was consternation and panic. They knew exactly what it meant for their air campaign. Their primary fighter's secrets were completely compromised. American pilots would learn to defeat it systematically. The psychological advantage of the seemingly invincible Zero was lost forever. Japanese strategists began planning replacement fighters urgently, but development took years and required resources. Japan increasingly lacked. The Zero would have to continue in service, increasingly obsolete, until replacements arrived. Those replacements would be too late and too few to matter. The Zero's capture accelerated the timeline of Japanese defeat significantly, by exposing vulnerabilities years earlier than combat attrition alone would have revealed them. In the final analysis, the most shocking discovery about the Zero was not its capabilities, but its vulnerabilities that could be exploited. American expectations had been shaped by propaganda and fear of the unknown. They expected a superweapon, an invincible fighter built by a mysterious enemy with unknown capabilities. What they found was a brilliantly engineered aircraft with fatal design flaws built into its very structure. No armor meant death from minor damage that American planes could absorb. No self-sealing tanks meant fire and explosion from single-bullet hits. Float-type carburetor meant engine failure under negative G-forces. Ailerons freezing at high speed meant inability to roll effectively in fast combat. Each weakness was the price paid for the Zero's impressive strengths. Maneuverability cost protection. Range cost robustness. Lightweight cost survivability in sustained combat. American designers had made different choices because they had different priorities and greater industrial resources. Pilot survival was paramount above all other considerations. Aircraft could be replaced by factories. Trained pilots could not be replaced quickly. Therefore, protection justified its substantial weight penalty. Armor was acceptable if it brought pilots home alive. Self-sealing tanks were mandatory despite reduced fuel capacity. Rugged construction was required even if it reduced theoretical performance. These choices reflected American industrial and cultural values about human life. America had the industrial capacity to build more aircraft and train more pilots simultaneously. They could afford to make aircraft heavy and expensive if those aircraft kept pilots alive longer. Japan could not afford this approach with limited resources. Limited industrial capacity meant aircraft needed to be simple, lightweight, and quick to produce. But that approach, rational in the short term, proved catastrophic in the long term. The story of the Akutan Zero became more than a war tale about a single aircraft. It became a case study in design philosophy, cultural values, and strategic thinking about warfare. Every aircraft embodies the assumptions and priorities of its designers and their nation. The Zero embodied Japanese assumptions about war, combat, and the nature of conflict itself. American fighters embodied different assumptions about industrial capacity, pilot value, and long-term strategy. The clash between these philosophies played out across Pacific skies for 4 years of brutal combat. Gradually, inevitably, the philosophy that valued pilot survival prevailed over the philosophy that accepted pilot sacrifice. The Zero Magnificent in 1941 was obsolete by 1943 and suicidal by 1944 when flown by inexperienced pilots. Not because Japanese engineering was inferior in quality, but because Japanese strategy was unsustainable in a long war. Today, the legacy of the Akutan Zero lives in aviation museums, history books, and tactical manuals worldwide. It remains the most significant captured aircraft of World War II in terms of intelligence value. The intelligence coup that helped turn the tide in the Pacific theater decisively. Tadayoshi Koga's unintentional sacrifice saved thousands of American lives and shortened the war by months, perhaps years, through the knowledge gained. The Zero itself remains a symbol of the Pacific War's tragedy and lessons. A beautiful aircraft, perfectly executed to meet its specifications, fundamentally flawed by the assumptions behind those specifications. Japanese pilots loved flying it for its handling and responsiveness. American pilots learned to defeat it systematically. Both sides recognized it as a masterpiece of lightweight design and a cautionary tale of valuing performance over protection. In the end, the most profound lesson was simple but vital. In warfare, as in life, choices have consequences that ripple forward. Choose speed over protection, pay in lives lost unnecessarily. Choose maneuverability over robustness, pay in aircraft destroyed. Choose short-term performance over long-term sustainability, pay in strategic defeat. The Zero made these choices consciously, brilliantly, fatally, and on a foggy July morning in 1942, when Albert Nack spotted red circles through the mist over Alaska. Those choices were laid bare for American engineers to study, understand, and exploit ruthlessly. The abandoned Zero in an Alaskan marsh became the teacher that revealed secrets. Not just how to defeat one aircraft type, but how to win the entire air war. That discovery, more than any single battle, helped ensure American victory in the Pacific. The price was paid by a young Japanese pilot who never knew his death would teach his enemies everything they needed to know.